Now in this key idea, we are looking at the rate of evaporation is affected by wind, temperature, and exposed surface area. So the following questions will rely on this key idea. So recall that the rate of evaporation is affected by wind, temperature, and exposed surface area. So let's look at question 22. When the temperature from wet clothes evaporate, the clothes become dry. At what temperature does water evaporate? Now we know, and we recall, water evaporates at all temperature. Okay, water evaporates at any temperature. So answer is 3. Question 23, Sharma wanted to conduct an experiment to see the effects of exposed surface area. So she set up these few things, and which of the following setups should he use? Now remember, fair test. Fair test means only one variable should change. Okay, so only one variable should change. So my focus is on exposed surface area. Okay, so if my focus is on exposed surface area, then this is the variable that will be changing. Okay, so let's take a look. A and B. Let's look at A and B. A and B, temperature of water 20, 30, and 20. The temperature is different, so this is not a fair test. Number 2, A and C. Let's look at A and C. A and C is 30, 30, okay, same. 120, 100. So my initial volume of water is different, so this is not fair already. Let's look at B and D. B and D, temperature of water is 20 and 30. So again, my initial temperature is different, so this is wrong already. So finally, let's look at C and D. C and D, my initial is 30, 30. It's fine. Volume of water is 100, 100. That's the same as well. The only difference is exposed surface area. This is 50, this is 20. So this is my answer. Answer is 4. Okay. 24. So I have this temperature graph. Temperature is to time graph. So which part of the graph shows the fastest rate of evaporation? So I want the fastest rate of evaporation. So recall, rate of evaporation is determined by heat. So that's why I have temperature here. So the higher my temperature goes, the faster my evaporation. So where will be the temperature that will increase the most? It will be this part here, D and E. So that's why my answer is 4, D and E. Okay. Now question 25. What factor caused the difference of water level? So some of the key things to take note. So let's take a look. Both placed beside each other. So that means my location is the same. Okay, at the same place, location is the same. Both contain the same amount of water initially. So my initial amount of water is the same. The only difference is after 3 hours, the volume of water in X was less than beaker Y. Okay, so what is the factor that caused the difference? So if my location is the same, that means the presence, okay, now presence of light, obviously this is wrong. Light doesn't affect evaporation. Presence of wind. Will the amount of wind be different for X and Y? It will be the same because, again, they are located at the same place. So same place means same amount of heat, same amount of wind. Okay, so both will be the same. Now, so presence of wind will not be a factor of why one evaporates faster than the other. Amount of water in the container, no, it really says the same amount of water initially. So this is wrong. The only possible reason and the only logical reason is exposed surface area. So that means one container could be something like this, the other container could be something like this. So although they are in the same place, because of exposed surface area, this one will evaporate faster as compared to this one. Okay? 26. So this one is steam. So recall, what is steam? So steam is basically hot water vapor. Alright, it's not the clouds that you see here. Okay, these clouds, we call it cloud or mist or something else. But steam is basically hot water vapor. Alright, so which of the following statement is correct? It is at A where the cloud is. Nope. So like I mentioned before, it is not the clouds. It is at B. So B is here, just above the kettle spout. Yes. Okay. Right. It will be there because it just came out from the kettle, so the hot water vapor will come out, and the moment it touches the surrounding, because the surrounding is cooler, it will condense, and that's why you see the clouds here. So this is actually water droplets. Okay, it's actually water droplets, not the water vapor. So C, where the water is, obviously not. Water is not the water vapor, steam. It's at D, inside the half-filled kettle, above the water level. Yeah, this is true because let's say I have water inside. When the water boils, this water will change to water vapor, and so the steam, this will all be water vapor. The steam will come out. Okay, and that's why it will travel out and out through the spout. Okay, so that's why this, everything here is the one that I'm dotting on red. These are all your steam. Okay, your steam will be here. Alright, so that's why Dylan will be correct as well. So my final answer is 3, Alvin and Dylan. Okay. 27. Relationship between temperature and rate of evaporation. Okay, so we recall that the more heat I have, the greater the rate of evaporation. So more heat equals more evaporation. So please write this down. More heat equals greater rate of evaporation. So which graph shows more heat? It's very obvious. This is the one. Okay, so as my temperature increases, the rate of evaporation also increases. Okay, so that's the relationship between temperature and rate of evaporation. Now 28. 50 cm cube of water into 12 identical bowls. So some of the key points. Okay, left 3 bowls at each of the 4 places. So I've got 4 places in his school, results shown below. Okay, so if then it says if each of the places receive the same amount of light. Alright, so same amount of light means this is the same amount of heat as well. Okay, so light and heat is quite closely related. Which one is the most windy? Okay, so we are looking at wind. Identical bowls. So what does identical bowl mean? So identical bowl means same exposed surface area. So that's what it means. So this is something you have to infer. Okay, so I'm asking which of the following will be most windy. So if it's most windy means rate of evaporation will occur fastest. So that means my bowl will evaporate the fastest. Okay, so high rate of evaporation means I will evaporate the fastest. So which is the one that evaporates the fastest? So if you look here, A, bowl 1 is 2, 3, and 2. B, bowl 1 is 3, bowl 2 is 4, 3. So A is the one that the numbers are the least. It takes the least number of days to evaporate completely. That means it's the fastest. Okay, so answer is 1. Now 29. So 29, this experiment. So she wants to investigate how the presence of wind affects the rate of evaporation of water. So please take note, this is very important. This is what she's trying to investigate, presence of wind and how it affects rate of evaporation. Okay, so she does all these things. 2 containers, fill them with water, blah blah blah. Now, let's look at container A. Location is corridor outside her classroom on a windy day. Okay. B, inside the classroom when there was no wind. Alright, so some of the keywords here, because we are looking at presence of wind, so the word windy, no wind should appear quite important to you. So which of the following variables must be kept constant to ensure that the experiment was fair? So you need to ask yourself, what is the variable that is changing? So the variable that is changing is the amount of wind, because this is what she's trying to explore, the presence of wind and how it affects the rate of evaporation. Okay, so obviously A must not be kept constant, because that's what I'm testing. So this is not what I'm testing. Let's look at the rest. Type of container used. Should I keep it constant? Yes, I need to. Temperature in both locations? Yes, I need to, because I'm not testing for heat. Amount of water? Yes, I need to. So all other variables must be kept the same except the one that we are testing. So that's the whole idea of fair test. So answer is 3. Okay. Now for this question, what's happening is you're supposed to state. Okay, so first thing that you must remember is state. You just say what happens. You don't have to give a reason. So you're supposed to state what happens to the hot milk and the ice cubes when this person immerse. Immerse means you dip the whole bottle into the basin. Alright, so you need to think what's going to happen to the hot milk. Now hot milk is going to lose heat, alright, because there's ice cubes around. So the ice will cause the water to be much cooler, so heat is going to flow out. Now what's going to happen to the ice cube? Because the ice cube is going to gain heat. You know that once ice gains heat, it will start to, yeah, that's right, it will start to melt. So this is how your answer should be like. So what's going to happen? The hot milk loses heat to the basin of water with ice cube and becomes cold. So keyword here is the hot milk loses heat. Okay, ice cube gains heat and it will melt. Okay, so the hot milk will become cold while the ice cube will melt. Now, after some time, Samuel observed the droplets on the inner and outer surface of the bottle. It's quite interesting, like both the inner and the outer surface of the milk bottle have water droplets. So here you are supposed to explain. So explain, you remember you must be scientific and specific. So you must give a very specific and scientific answer. So why? Let's discuss this before I show you the answer. Why would there be water? Okay, first let's talk about inside. Why is there water droplets on the inside? Well, hot milk, what will happen to the water? Yeah, it will start to evaporate, right? So this hot water vapor, the water vapor will start to evaporate. And when it touches this cooler surface, what's going to happen? Yes, it will condense because it's cooler. Okay? How about the one on the outside? Now, because I'm immersing it with ice, I'm going to change color. Immersing it with ice, this ice, the bottle will lose heat. Okay? Correct? So we know that this bottle is going to get cold because of the ice. So once this is cooler, the surrounding water vapor will also condense onto the outer surface, and that's why water droplets are found both inside and outside, because this bottle is going to be much cooler compared to inside and outside. Can? So this is how your answer should be like. So basically what happens is water will evaporate from the hot milk, touches the cooler surface of the bottle, loses heat and changes to water droplets. So remember, when you explain how, this basically is condensation. Okay, so explanation of condensation, there are a few things. One is that evaporation occurs, the water vapor touches the cooler surface, loses heat, and then change to water droplets. Okay, so these few things must be mentioned all the time. Cooler surface, lose heat, then change to water droplets. Same thing, water vapor from the surrounding air. So I have water vapor, touch the cooler surface, lose heat, and then change to water droplets. So these four things must always be there when you're talking about condensation. Alright, question 31. Let's look at the key words in this question. 3 similar beakers, so they are the same, 100 ml each, in 3 different conditions. Why is she doing it? She's doing it to test the effect of the rate of evaporation. Okay, so this is the table that she records down. So I have beaker A, volume of water. This is after a few hours. Okay, so volume of water after a few hours, 85. For B is 62, C is 57. So I want you, we need to write beaker A, B, C in the correct blanks below. So let's take a look. So, why would there be a difference in the amount of water? Basically, the conditions are different, so the rate of evaporation differs. So we've learned that heat, wind, and exposed surface area affects the rate of evaporation. Exposed surface area in this question is not applicable because of the fact that there are 3 similar beakers. Okay? So we are left with heat and wind. So if you look here, fan, this is wind. My lamp, this is heat. So for this beaker, I have both fan and lamp, so that means I have both wind and heat. So if I have both conditions combined, my rate of evaporation will be the fastest. So which is the one that will have has the least amount of water? And that's C. So C will be this beaker that has fan and lamp, because its evaporation will be the fastest. For this second one, it's fan only, so I have wind. So obviously this will be B, because it is the next least amount of water. And for A, because I have none of the conditions, so it will evaporate the slowest. It will still evaporate, but it will evaporate the slowest. So you're supposed to name 2 factors that affects the rate of evaporation for this experiment, so like I said, exposed surface area is not a factor here. So the two factors will be wind and heat. Alright, fairly straightforward. Now question 32. Filled 100 ml of water in each of the containers as shown below. So I've got 4 different containers and they look different. Now, he placed 3 different containers under the sun and 1 in the classroom. So my location is different for one of them. Okay? So then you need to ask yourself, what's the aim of this experiment? What's the aim of this experiment? So we need to find out what is the variable that is different. So if you look at the containers look different. Okay? Now, then what other variables? The location is different, but then for 3 of the containers, the location is the same. Okay? So although it seems like he is changing 2 variables, but the main variable that he's changing is the exposed surface area. So the aim of the experiment is to find out whether exposed surface area affects the rate of evaporation. Now, but if your answer is whether the position or the location affects, that is true as well, because that is the another variable that he's changing. Okay, so we are not too sure what exactly is his aim. Alright, let's carry on. Now for part C, sorry, this should be part B lah. Now, how would the exposed surface area of a container affect the rate of evaporation of water? So if we look at what is happening here, okay, amount of water in the beginning, okay, the amount of water in the beginning is all the same, but if you look carefully, A 20 ml, B 25 ml, C 60 and D 75. So what do you notice? This has the least amount of water at the end. This is the second least amount, and this is third, and this is obviously the most. So what do you notice about this experiment? Okay, well, basically this proves that the larger my exposed surface area, so these 2 surface area is relatively large, this 2 is quite small, and this one obviously is, D is obviously the smallest, and because of that you see the amount of water left at the end is the highest, while A and B, the amount of water left is very low. Okay, so that tells me that the larger the exposed surface area of a container, the faster the rate of evaporation.